Scientific notation. An exponent tells how many times a number is to be multiplied by itself. For example, 2 to the third power means 2 times 2 times 2. 2 raised to itself 3 times. Another example, 5 to the fourth power is represented as 5 times 5 times 5 times 5. Notice we have 4 5s written. Also, 2 times 2 is 4. 4 times 2 is 8. 5 to the fourth power, again, means 5 times 5 times 5 times 5. 5 times 5 is 25 times 5 times 5 is 25. And we know that 25 times 25 is equal to 625. So another way to represent 8 would be 2 to the third power. And another way to represent 625 would be 5 to the fourth power. Scientific notation is the value of a number that is equal to or greater than 1 and less than 10, multiplied by the power of 10. In science, very large and very small numbers are written using scientific notation. Example 1. The distance of the sun is 93 million miles from the Earth. Okay, we can write this number in scientific notation. Again, the thing to remember is that we want our whole number to be between 1 and 10. So the number of interest is the 9. Okay, we have a decimal point here. Now let us count to see how many places we need to move our decimal point. In this case, we're moving the decimal point to the left. So let us count. 1, 2, 3, 4, 5, 6, 7. So to write this in scientific notation, this will now be 9.3 times 10 to the power of, again, let's count, 1, 2, 3, 4, 5, 6, 7. 9.3 times 10 to the 7th power. That's the key. Example 2. The average distance from Mars to the Sun is 141,500,000 miles. Again, it's a very large number. We can write this in scientific notation. That way the number is a lot easier to deal with. So, moving our decimal point, again, to the left. Let us count how many places we need to move it. We have 1, 2, 3, 4, 5, 6, 7, 8. Almost got confused there. So we write that as 1.415 times 10 to the 8th power. Now notice these are positive because we're moving the decimal point to the left. Okay, that's going to be different from example number 3. Example 3. A film of oil measures 0.000005 centimeters. Again, we're going to write this in scientific notation. Now the difference between the first two examples and example 3 is that now we're moving the decimal point to the right. So let us move. Again, the thing to remember, we want our whole number to be between 1 and 10. 1, 2, 3, 4, 5, 6. So now we can write this as 5 times 10 to the negative 6. Why negative 6? Again, because we're moving our decimal point to the right. Examples of writing scientific notation as a number. Let's look at example 4. We have 4.3 times 10 to the power of 5. Well, this is a positive power, so we know we'll be moving our numbers to the right. So we can write this as 4.3. We know we have to move the decimal point 5 places over to the right. So let us count. 1, 2, 3, 4, 5. And let us now fill in our empty spots here. 0, 0, 0, 0. So this converts over to 430,000. Example 5. 2.6 times 10 to the negative 4 to the negative 4. Negative, that should tell us that we're going to move the decimal point this time to the left. So we have 2.6, and we need to move the decimal point to the left 4 places. Let us do that. 1, 2, 3, 4, and let us fill in our gaps. 1, 2, 3. 2.6 times 10 to the negative 4 is equal to, or equivalent to, 0.00026. We have 2 different ways to represent the same value. Okay, it's a good idea to look at this chart and make sense of it, because making sense of this chart will help us to better understand what we mean by scientific notation. We have our number and our power of 10. 10 to the power of 1 is 10. 10 to the power of 2. 10 to the power of 2 can be represented as 10 times 10, and 10 times 10 equals 100. That's how this all kind of connects together. 10 to the power of 3 is represented as 10 times 10 times 10, and we know that's equal to 1,000. See the connection? Then, of course, 10 to the 4th power is represented as 10 times 10 times 10 times 10, which is 10,000. Okay, there's a connection. This is what this means. This column is, again, a very simple concept to understand. We know we have our number and our power of 10. 1/10 is represented as 0.1, which is represented as 10 to the negative 1. 1 over 100 is represented as 1/100th, or 10 to the power of negative 2. And then we have 1 over 1,000 is 1/1000th, which is represented as 10 to the negative 3 power, to the negative 3rd power. Then we have 1 over 10,000, which is represented as 0.0001, which as a power of 10 is 10 to the negative 4 power. It's a very simple concept. The key is to look at this and make sense of it. And then from there, that will help us better understand what we mean by scientific notation.
Scientific notation. I'd like to first of all show you the difference between these 2 calculators. And this is a normal calculator that we use. It's in a large version for teaching. But this is a scientific calculator. And what this scientific calculator has 3 very important buttons. You don't need it for this course, but you need it for trigonometry. And that's sine, cosine, and tangent. But this calculator is also useful for scientific notation. Now I'm going to explain why. I'm going to take the speed of light, which is 186,000 miles per second. Now I'm going to put this in, and we're going to find out how many miles it is in 1 year. So 186,000, that's miles per second, times 60, that's miles per minute, times 60 again, miles per hour, times 24 miles per day. Now watch what happens to this calculator. Now we're going to plug in the number 365 for days per year. Now watch what happens to this calculator. Times 365, that's days per year, equals, and notice on the top there, we get an error. This calculator cannot put in that number. It doesn't have enough spaces for that large number. Now watch what happens to this scientific calculator when we put in the same number. 186,000, that's miles per second, times 60 equals miles per minute, times 60 miles per hour, times 24 equals, now notice we have this number 1.60704 to the 10th power. Now watch what happened to this calculator when I times it by 365. This calculator created an error. Times 365 equals 5.865696 to the 12th power. So after this decimal point, you have 12 spaces, and whatever is missing, you just add zeros to it. Now, what do you think would happen if we multiply that number by 1,000? We're adding 3 more zeros to it. Now, watch what happens to the 12. It should come to 15. Times 1,000 equals, it goes to the 15th power. Now, I'd like to point something else out. In the book, you have this problem. Distance of the sun is 93 million miles, or 9.3 times 10 to the 7th power. Do not do this. 9.37. That is not 9.3 times 10 to the 7th power. You have to put times 10 to the 7th power. Because what this number means, it's an exponent. It's 9.3 times 9.3 times 9.3, 7 times. So in doing scientific notation, make sure you write it properly. Now there's another problem that I'd like to show you. This is just a trivia question. How much is a billion? 1 billion. Now say you could earn $1 for every second and you put it away in the bank. How long would it take you to earn $1 billion? Let's go to the calculator. First of all, we'll clear this calculator. We can do it on this one. All clear? All right, so you earn $1 every second times 60. So in 1 minute, you earn $60. Could you imagine earning $60 in 1 minute? Boy, you would love to earn money like that. All right, times 60. So you're earning $3,600 in 1 hour, times 24 equals $86,400 per day, times 365 equals. Now we're going to put that in memory plus, and let's take 1 billion. That's 1, that's 1,000, 1 million, 1 billion. We're going to divide that by memory recall equals, so it would take you 31.7 years. So if you earned $1 every second, it will take you over 31 years to have earned $1 billion. I like to show you various scenes with our military aircraft. As you look at the scenes, think of all the math and science used to build the aircraft and the aircraft carrier. Remember, the men and women designing and building this equipment were once just like you learning algebra.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.